This problem asks us to identify the region represented by B union C. So this is finally a problem where we would actually use those Roman numerals. So B union C is all of this and all of this, because union means unite. So just name those regions. Would be region 1, 2, 5, 6 for this part, and then 4 and 8. All right, here is a multiple choice problem, which the way you look at this, you might be able to pick out what the answer is right off the bat, but at the very least, we need to start filling some things in, and it would give us good practice anyway. We know to do this, we need to start in the innermost region, which is A intersect B intersect C, and the only element that's in common to all three sets is 12. So in this little position here, I put 12. Then I will look at set A intersect B, and what's in common to set A intersect B is 12, 14, 16. And I should have little brackets around all this. I'm just being lazy because I'm trying to go fast. A intersects C. What's in common to A and C is just 12. And B intersects C. What's in common is 12, 18. So let's just stop right there and see what we can fill in. And here's 12. A intersect B has to be 12, 14, 16. So that's that. A intersects C is only 12, which we've already got that listed, so there's nothing that's going to go here. And B intersects C is 12 and 18. 12 is already positioned, so we go to 18. We have enough information to know what the answer is. The only one that works for us is going to be this one right here that has the 12 in the middle and the 14 and the 16 up here. But let's just keep on going to give you a little bit more practice on these. The next thing we want to look at is just what goes in A. And what goes in A is what's not already been placed. We've already placed 12, 14, and 16. So what goes in A is just 20. To place what's in B, we have to eliminate 12, 14, 16, 18. 12, 14, 16, 18, and 6 and 8 will go up here. And set C, we have 12, 18 already placed, so knock off 12 and 18. That means a 10 is going to go right here. And then don't forget your universal set. We can eliminate all of these things from the universal set and write down what's going to be down here, which is just 22. How do I know that's 22? Because I can knock off 20, 14, 16, 12, 18, 6, 8, and 10, and what's left is 22. Now, this is something a little different. You're being asked to prove that two sets are equal by using a Venn diagram. So I want to know, is A union B complement equal to A complement intersect B complement? The only way to do this is just to do one at a time, color things in, and see what's left. To do A union B complement, remember what A union B is. A union B is all of this. A union B is all of this. But I want the complement of that. So I don't want that. I need all this stuff out here on the rim. So I'll erase this. And we're going to highlight just that outside part. So this is all my A union B complement. And then come over here and take these piece by piece. If I want to do A complement, this is A. The complement of A is all of this. And sometimes it helps to have crayons or markers to help you see what's what. That's the complement of A. The complement of B is not this. Complement of B is all of this. And we are looking for the intersection. Intersection means what's in common. As far as my colors go, it's what's colored both red and green. This is just red. This isn't colored at all. This is just green. What is colored red and green is all of this stuff out here. And is that equal to the one over there? Yes. So we would say the complement of A union B is the same as the complement of A intersected with the complement of B. Another example, we're doing A intersect B complement. A intersect B is this part right in here, but we want the complement of that. So that means we want everything but that colored in. So let me erase that and color in the other, which is all of this. You don't have to stay between the lines, just to give yourself an idea of what's being colored in. A complement union B complement. A complement is, this is A complement is all of this. B complement is all of this. Now what we are looking for is the union. We're not looking for overlap. Union means just whatever's colored is colored. And these two are the same. So those are the same. Now, those last two problems are very special because they lead to what's known as De Morgan's laws. De Morgan's law says this: A intersect B, the whole thing complement, is the same as the complement of A union the complement of B. So it's like this knot will distribute through here. It changes A to A knot, changes B to B knot, and it changes the intersect to a union. Same thing with A union B knot. That knot changes A to A knot, B to B knot, takes the union and makes it an intersection. Sometimes knowing this can be helpful and maybe a shortcut here and there. So we have these three sets, the universal set A and B. We want to find A union B knot. So A union B first will be B, C, E. But I want the complement of that, so I need to eliminate B, C, and E from the set, and what I get is the set that contains A, D. Now, according to De Morgan's laws, look at this. This is A union B knot. It should equal A knot intersect B knot. Let's just check that out and see if it works. It worked for the Venn diagrams. Let's be sure it works for the sets in roster form. A knot means eliminate BC, gives me A, D, E. And I want to intersect that with B knot. B knot says take away B, C, E, which is A, D. And what I want to do is intersect, which means find out what's in common, which is just A, D. So we have verified De Morgan's law with that example. Switch this around and do A intersect B knot. So first start with A intersect B. A intersect B, what's in common is B, C. But if I want the complement of that, I have to go up here and eliminate BC, and I'm looking at A, D, E. Over here, A complement means wipe out the B and the C, which gives me A, D, E, union with B complement. B complement says wipe out B, C, E. I'm left with A, D. I want to union these. Well, ADE union with just AD is ADE. So what that did is just verified for you that De Morgan's law works with set notation rather than just the Venn diagram notation. Here's a little more complicated problem. We want to use a Venn diagram to prove that this set and this set are equal. Now, if it says prove that they are equal, they are equal. They better work out to be the same. So to do this color-wise with the Venn diagram, I need to do B intersect C, and I know B intersect C is all of this. Yes, I know that little portion in here is A intersect B intersect C, but all I'm doing is coloring B intersect C. This blue portion I've colored in is B intersect C. And then A union with that is all of A colored in. So that is what my Venn diagram colored in should look like over here. So A union B is all of this. Then I need to do A union C, which is all of this. Now, can you tell from the colors we need the intersection, so we're looking for what's double colored. This right up in here is colored green and yellow. This is just green, I don't want that. This is just yellow, and this portion in here is green and yellow. So we are looking at all of this and this, so we have verified that those are the same regions when we colored them in. Now this says use the Venn diagram to determine if the given statement is true for all sets A, B, and C, and consequently is a theorem. So I need to look at this first. A intersects C. Now I'm not going to color this in. Instead, I'm going to make a listing of the regions. A intersects C. A intersects C is this right in here, which is regions 4 and 5. I want to union that with set B. Set B is all of this, which is 2, 3, 5, 6. So I am unioning this with this, which will give me in order 2, 3, 4, 5, 6. That's what I get for the left side. For the right side, I'm doing A union B. A union B is all of this together, which is 1, 2, 4, 5, 6, and 3. That's A union B. 1, 2, 1, 2, 4, 5, 6, 3. I need to intersect that with C. C is 4, 5, 6, and 7. Intersect means what's in common. So I have a 4, I have a 5, I have a 6, and that's all I have. So are these two sets equal? No, they are not.